In this lesson, we're going to be talking about transformers and how they work in your air conditioning systems. Now, remember, we have line voltage, which comes in an air conditioning system most often at 240 volts or the air handler at 120 volts. So we have to do something with this to make it safe and usable in a low voltage application so that there's no chance of shocking hazard or anything else, and could put it into control voltage. So the transformer is a non-mechanical electrical device. It basically has two windings. The transformer primary is the winding to which voltage is supplied. The transformer secondary is the winding from which output voltage is supplied. And then in the center of the transformer, there's a core. It's a center iron portion that actually has the other windings wound around it. So this is the electrical symbol or the schematic symbol for a transformer. The primary and the secondary will always be marked, but again, as a reminder, there is no electrical connection between the primary and the secondary winding of this. Let's say the top one is your primary, it's a coil of wire. The bottom one is your secondary. And again, this is just an example because it could be upside down. In between here is your core. But notice there's no touching of the primary and the secondary side. Everything is done here with magnetic. Okay, the way this actually works is the input AC, or the primary alternating current, creates a magnetic field. That magnetic field induces voltage onto the secondary windings. By what I mean voltage is anytime you put a coil of wire into a magnetic field, you're going to start getting current out of the coil of wire. The strength of the output depends on the strength of the input and the number of windings of both the primary and the secondary side. That's called a voltage ratio. The voltage ratio is equal to the turns ratio. The current ratio is opposite of the voltage ratio. So a step-down transformer says that if the primary turns are greater than the secondary turns, the voltage will decrease and the amperage will increase. Okay? So a step-down transformer decreases the voltage but increases the amperage. So if a transformer is 120 volt input and a 24 volt output, the voltage ratio is 5 to 1, but the current ratio is 1 to 5. A step-up transformer says that if the primary turns are less than the secondary turns, the voltage will increase, but the current will decrease. For air conditioning, most often you're going to use a step-down transformer. Where we see step-up transformers is with oil and gas ignition in the heating side of things. The VA rating, or the volt amp rating, is the secondary voltage multiplied by the secondary amperage. So if the secondary current draw is more than the VA rating will allow, the transformer will burn out. You're going to see transformers that basically say 40 VA, 60 VA, 50 VA. That's volts times amps. Control voltage will normally be 24 volts because it's safer and less costly. So most of the transformers you're working with for control voltage is going to be 24 volt, and it could be most are 40 VA, but you can have to go higher. This is an example of a 24 volt transformer. Okay, back here you have your wiring, and up front you have an R and a C terminal. This is your power source for your control voltage side. So how to check if a transformer is pulling too many volts or too many amps? Look at the VA rating. It's the maximum secondary side voltage. Okay, so what do we want to look for in a good transformer? Okay, it will have an ohm reading on the secondary side. It will have an ohm reading on the primary side. Notice I'm not giving you any numbers here. And it will have no continuity between the primary and the secondary side. In other words, if I put my ohm meter on one of the wires coming to the primary and put the other lead onto one of the secondary terminals, should show OL. It should also show OL from any wire or terminal to the ground. What we're looking for on a bad transformer, OL or infinite on the secondary side, OL on the primary side, continuity from PS to SS, which is primary to secondary, continuity from primary side or secondary side to ground, or voltage on the primary side, but no voltage on the secondary side. And I'm going to tell you this last one is what you are going to have most often. Now, there's also a thing called multi-tap transformers. They're more versatile for applications. The secondary side will be 24 volts, but the primary side can be 120 volt, can be 208 volts, can be 230 volts, can be 277 volts. One wire is going to be called a common. Most often, by the way, that wire is going to be white. The common wire will be involved in all voltages used. Any wire you're not using will have voltage and must be individually capped. Don't throw them under one wire nut. This is an example of a multi-tap transformer. Okay, your two secondary leads are on one side of it. Okay, that's where your 24 volts come from, your two secondary leads. Then you might have four primary leads. That white is usually going to be the common. Okay, so that would go to L2. And then depending on what voltage you're using, you will use one of these other leads and you will individually wire cap the others. Okay, and if you look at this transformer on the side of it, there's a label that will tell you what wires to use for what voltages. It's pretty easy to mark. Okay, this is a schematic diagram with a transformer in the diagram. It's actually a fan diagram that you'll probably see in the air handler. Okay, so here we have our transformer. Our primary side is the side with 120 volts on it. Here we have our transformer again with 24 volts coming off the secondary side going to R on the thermostat. Okay, coming out of Y on the thermostat, which is our cooling part of the thermostat, we have a contactor coil. Okay, coming out of that, we return to common. Notice there's no electrical connection between the primary and the secondary side. And this is how we want to make sure we see it drawn on any diagrams you may draw as a part of this or any other course. This is just a slightly more complicated system. Again, it's a cooling system. Okay, we have several parts of this. We have our transformer down here. We have an indoor fan relay coil. We have a contactor coil. In our primary side, we have our indoor fan relay contact, which, by the way, matches initials to that coil. We have our indoor fan motor. Up here we have C and C, which are the contacts that connect that coil marked C. But you'll notice again, there's no electrical connection between the primary and the secondary side of the system. This is just a look at the idea of a step-down transformer. Okay, I have 1,000 turns of wire, and that's very possible. I'm not going to go count them. I'll believe the manufacturer. But I have 1,000 turns of wire on the primary side. I have 500 turns on the secondary side. Okay, so that is going to put off 60 volts to the 120 volts because 500 divided by 2, okay, it's exactly half. Okay, so that's basically all about transformers, and you're going to pick up more on them when you actually start working with them. Primary voltage is very dependent on what you're connecting it to. Secondary voltage, most often, it's rated at 24 volts, but you're going to be seeing readings of 26 to to 24 volts. If you ever read actually 24 volts on a transformer, you do need to go back and find out why the circuit is using more amperage than it should be.